Good day and a very warm welcome on behalf of NTI Audio for today's webinar. Today we're going to talk about noise curve measurements with the XL2 analyzer, or if I may express it in different terms, we're going to discuss a method to assess, to determine the perceived level of annoyance, the perceived sound level in a room. If you have prepared your own XL2 analyzer for this presentation to follow the steps that I'm going to show you, please keep in mind that the noise curve measurement requires the spectral limits option, which must be installed on the XL2 analyzer. My name is Markus Becker, and I'm assisted today by Bruno Niksch, our product manager, who will mainly take care of your questions during the presentation. We have prepared a couple of topics for today, starting with an introduction, why and we are talking about noise curve measurement and what does that mean. We're going to explain some terms and definitions and provide some examples of such noise curves. We will then show you the typical steps for executing such a measurement, followed by a practical presentation. After that, we will summarize what we have shown to you and provide some application hints before we end the session with the question and answer session. The overall presentation will be in the range of about 30 minutes. So what are we talking about? What are we looking for? We want to have a method that allows us to qualify the sound level in a room, the level of annoyance in a room by a simple measurement. And simple means the target would be a single value result. Not a spectral curve, but just one value that gives us a good and reliable information how high this level is. The challenge thereby is that our human hearing perception depends on the frequency of the different sound components. So we have to somehow correlate the actually present sound with our hearing perception. And a solution to do that in a simple way was to fit the Z-weighted, which means the unweighted noise spectrum, into this noise curve scheme. What does that mean? The noise curves originally were derived from the loudness curves expressed in phone. Those of you who are in the business for a longer period of time, you maybe remember the phone unit for loudness, and there were this scheme of curves of equal loudness, equal perceived loudness, and they built the base for the noise curves. So this would be an example of such a noise curve scheme. And what we do now is we measure the the present sound level in a room in octave bands and plot it into that scheme. And you see here this black curve shows us the corresponding level values for each octave band. And now we take a look which is the noise curve that is the highest one that touches our measurement curve. In this case, it would be this point here. And you see the orange curve, it's the NC45. And the standard now says that the noise curve result of this measurement would be the next higher curve, which is the NC46, because the NC46 curve does not touch our measurement curve. Keep in mind, in the scheme I have only plotted a selection of noise curves, so there are many more. Actually, there are 4 curves in between each pair that you see here. It's just the picture would be overloaded if I would plot all noise curves, but the standard has defined them, and the test instrument, of course, also considers all these existing noise curves for its measurement. So the principle is very simple. You measure the spectrum and you take a look which is the lowest noise curve which does not touch the measurement result curve. In this table, you see a couple of terms and definitions, starting with the good old sound pressure level, which is a wideband measurement, and that allows you to gather a first quick impression, a first assessment of the situation in a room. The SIL, the speech interference level, is a specific measurement. It is built by averaging the sound level of 4 octave bands that you can see here, the upper 4 octave bands. And this SIL gives us a measure of the effect of noise on the speech intelligibility. It is part of the standards that you see below, and it is sometimes required, so it may be that you have to measure this result as well. Then here we see the typical noise criteria or noise curve measurement, starting with the noise rating, which is defined in the ISO 1996 standard, and which is mainly used in the European Union. Then we have the noise criteria defined by the NZS 12.2 standard from the year 2008, which is more popular in the United States. We have the room noise criteria, which is defined by the same standard, and different to the upper two standards, which refer to environments where there is no low frequency fluctuations or surges. The RNC has been specifically designed for environments where you have rumble, so low frequency fluctuations present. They typically are originating from heating, ventilation, air conditioning systems, and this RNC standard measurement requires an level acquisition every 100 milliseconds for a period of time, minimum 20 seconds, and these values also go into the overall result. Then we have two older standards, the room criteria and the preferred noise criteria. They are kind of predecessors of the upper standards, but still in use. The room criteria has a specialty by indicating a hissy or rumbling environment. All these standards that you see here, including the SIL, are supported by the XL2 analyzer. Here you see some examples of the noise curves that are defined by the corresponding standards. You see there are some differences between these curves, and the reason is that after having started from the aforementioned phone loudness curves, it turned out that in practice, depending on the environment where you wanted to execute such a measurement, there were some amendments required to truly represent the hearing perception of the perceived sound level in these rooms. And these differences, these amendments have gone into the corresponding standards. That is the reason why these curves have a slightly different shape. Now let's talk about a typical test execution. The first step is you have, of course, to know which noise curve standard should be applied. This may be defined by the national body, the law in your country where you're located, or by the person who is asking you to execute the measurement, that he tells you which standard he wants to know, the result of which standard. Then second, you should measure the noise spectrum in the unoccupied room. That means the room there should be no persons present. So let's, for instance, talk about an open plan office. The office should be empty because you want to measure only the background noise. You don't want to have the noise of all the people talking to each other and talking on the phone. They have to be out of the room. So you really want to focus on the background noise in that place. And then you have to verify whether this background noise is below the target value. And here in this table, you see some typical target values for the corresponding locations. When you have executed that measurement, you can analyze the result. For instance, let's assume that you have a result that is exceeding the target value. Then you can look at the detailed measurement results to find out in which frequency range there is the problem. For instance, in the high frequency range or in the low frequency range, and this information allows you to to optimize the acoustical situation in the room with a very targeted measure, to apply damping material which is used, which is able to lower the background noise level in the corresponding frequency band. And then, which is anyway recommended, it is always nice to know whether there are rumbling or low frequency fluctuations present in the room. These low frequency fluctuations sometimes can hardly be heard if you just listen for a moment, but in the long run they have an impact on our perception, whether we are feeling fine or not so good in that room. So it's always good to know whether they are present or not, and the RNC curve or the RNC curve measurement actually is a very good measure to answer this question. Some words about the microphone positioning that you should apply during the measurement. First of all, you should sweep around the entire space, which means you should silently walk around the space that you want to measure during these minimum 20 seconds, can be more. In many occasions, it is recommended to extend the measurement duration beyond these minimum of 20 seconds. So cover the whole area by silently walking around during your measurement. Second, you should hold the microphone in a specific height above ground, depending whether the room is typically used to stand, where the people are standing, or whether they are sitting. So these measures that are given here don't need to be obeyed exactly. It's not a question of a single centimeter or inch, but it's just a recommendation in which range you should hold your microphone during the measurement. And last but not least, keep in mind not to come too close to reflecting surfaces, be it the floor or a wall or an intersection or even a corner. Again, these values don't have to be obeyed by exact measure. It's just an indication to stay away from such reflecting surfaces to avoid that the reflections would compromise your measurement result. Well, we are at the point of our practical presentation. I have here an XL2 on my desk that is connected to my PC via USB link, and I'm running the XL2 projector software, which is, by the way, available free of charge from NTI Audio. So please get that software if you don't have it and if you need it. And at the end of my presentation, I will also show you the so-called noise curve reporting tool. This is a Microsoft Excel spreadsheet that you can use for documentation of a previously acquired measurement. This is the content of the screen of my XL2. And what you see here is the noise rating curves. You see that here, these shaded curves, they represent the noise rating standard. And in addition, you see also here a gray area. And this gray area actually represents the noise floor of my test instrument together with the connected microphone. I guess you know that every measurement system, every measurement instrument has a kind of a lowest level that it can measure. Below that, there is some inherent noise within the electrical noise within the instrument, and this is represented by this gray area, which means you cannot measure a sound level below this limit here. But keep in mind, this is really extremely low, so you will most certainly never encounter a space which is more silent than this internal noise floor. So the first thing I do, I select the noise curve measurement from my menu, and then I would select the standard that I want to apply. You see here the noise rating, the ISO 9096 standard, as I said, very popular in Europe, but let's go for the noise criteria. And by the way, when I toggle here through these standards, you see in the background, the instrument always immediately applies the corresponding curves and shows them on the screen. So let's go for the noise criteria. And then the next preparational step would be to define the duration of your measurement. Here we have 30 seconds by default, which is our recommendation, but for the sake of just keeping this presentation not too long, I will reduce it to 10 seconds, which is actually below the minimum requirement of the standard, but it's enough to give you an impression what happens during such a measurement. So I will start the measurement by pressing the play button, and I will keep silence for that time for these 10 seconds, just to make sure that I'm only measuring the actually present background noise in the room where I'm sitting in. So you have seen the countdown down here, or the run indication up here, which indicated that the measurement is in progress. You have seen that very quickly there was this black curve visible on the screen. This is my measurement result curve. And you see here the cursor has automatically found that point of my measurement curve. That is the highest one in relation to the noise curves. So this is the point actually here at 1 kilohertz that gives me this result of 31 for the noise curve standard 2008. You also see here on the right-hand side the SIL result for this measurement. And at the end of the measurement, I have automatically saved the result. And this gives me now the opportunity to take a look at the result in a different standard. So for instance, I could take a look at the RNC result, and I don't have to redo my measurement. The XL2 will automatically take the saved raw data and calculate the corresponding result in the selected standard. So this is a very comfortable means that allows you to get a good impression of all these standards and what the corresponding results would be. So let's assume we want to save this RNC result as well. So all we have to do, we have to select it. We go here to the Save menu and say Save Test. We can amend the name of that recording and save it and save this RNC result. Secondly, I can press the Pages button on my XL2, and that will toggle between these two pages. They are somehow on the same level. So the second page here gives me an indication whether there have been major fluctuations, low frequency fluctuations present during my measurement. Here the answer is yes. The calculation, how we get to that result, is fixed, implemented in the XL2 analyzer. So if there is a yes here, that gives you the indication that you definitely should take a look at the RNC result. And another hint I want to give you is that by pressing the limit button on your XL2, you can take a look at the live situation. So now I'm pressing that limit button, and the reason why I'm talking here is that there is a very flickering curve now present, but this gives me the chance to toggle between the recorded result and the live result. Just press the limit button. Well, that was the part of the execution of that test, and I want to show you now this Excel spreadsheet with the noise curve reporting tool. I have opened it here, and by pressing the load file button, here you see I have previously saved 4 different results. So I open, for instance, this noise curve result here, open. Here you see all the detailed information, the serial number of the XL2 and of the microphone that has been used, and so on and so forth. You see here the measurement standard that was applied, the noise criteria 2008, and then by going down here to the corresponding tab, noise NC 2008, I see the acquired result graphically plotted into this noise curve scheme. Now I can edit the information about the name of my client and where I have executed this measurement and so on. And in this way, I can very easily create a nice report for my measurement. If I want to see the result of another measurement, for instance, then I have to again open the corresponding result file. Now we have the noise rating, which is here, and it will be plotted in the corresponding graph of that tab. The other tabs are empty, of course, because I can only open just one file at a time. This spreadsheet is available from NTI free of charge, as mentioned before. So if you're interested, please let us know and we will be happy to share it with you. So let's get back to our presentation and summarize what we have seen. First of all, just to keep in mind that the spectral limits option has to be installed on your XL2 analyzer. Second, you may select the required NC noise curve standard before you start the measurement. You should get ready for the measurement by making sure that the room where you are in is unoccupied, and this is also very important, the environmental situation is as usual. So you should not execute such a measurement, for instance, at midnight time when we are looking for the background noise in a normal office where people are working at daytime, but we should execute the measurement actually during daytime when the outside traffic, for instance, is as it is normal. It's just no people in the room, but the external situation should be as usual. Then you should press the start button to start the measurement and continue for minimum 20 seconds. We recommend rather 30 seconds. If an unforeseen incident happens during the measurement, a very loud noise, which is absolutely not typical, then you should stop the measurement, omit it, and restart it. Then, as I showed you before, you can press this Pages button to see the second screen that gives you the indication and the feedback whether large low-frequency fluctuations have been present during the measurement. However, keep in mind that this second page is only available for the NC and the RNC measurements that are defined in the NC S12 standard from 2008. Then, if you like, you can use the cursor to get the readout of the individual octave band data. Let me show you that briefly. I go back here to my XL2. By moving the cursor here to this frequency field, pressing it, you can manually control and see at what level the corresponding octave results are. So this is a way of manually just getting more information from my octave measurement. When you exit that mode, the automated cursor will immediately jump back to this highest point in the NC curve scheme. Then, when you like, you can press the limit button to see the live view. I have shown you that before. And if you want, you can look at the results of different standards after you have executed the measurement by selecting them from this menu, and of course you can also save them on the SD card of the XL2. And this actually should be done if you want to post-process, if you want to document different results after you are back in your office. So make sure that all these measurements that you have that you are looking for are saved on the SD card, then they are available for your documentation. And please take advantage of this spreadsheet that we are providing upon request. Well, I'm at the end of our presentation. Please keep in mind, if you have any further questions or if you need any specific support, please don't hesitate and contact us here in the headquarters of NTI Audio in Liechtenstein, or at any of our subsidiaries worldwide, or our independent partners, which are now not on this list, but I guess you know them and you may ask them at any time. They will be happy to support you. I would like to say goodbye at this point. Thanks for your attention and see you soon.